Welcome to True Projects. In this video, we are going to explain about data poison detection schemes for distributed machine learning. Introduction. The project examines the application of distributed machine learning (DML) in situations where a single node cannot handle a large dataset in a reasonable amount of time. A typical DML system separates the dataset into different portions and distributes them to dispersed workers who complete the training task and submit their results to the center. However, as the number of dispersed workers grow, it becomes more difficult to ensure each worker's security, raising the risk of attackers poisoning the dataset and influencing the training outcome. Depending on whether the center shares resources in the dataset training activities, the project presents data poison detection strategies for basic DML and semi-DML. The experimental findings support the effectiveness of the proposed strategies. Objective. The project's goal is to offer data poison detection algorithms for distributed machine learning (DML) systems that can detect and prevent attackers from poisoning datasets and influencing training results. The project divides DML into two types, basic DML and semi-DML, and it proposes a novel cross-learning mechanism for detecting poisoned data. In addition, the project develops a mathematical model to determine the ideal number of training loops. The project provides an improved data poison detection system for semi-DML to give better learning protection with the help of the central resource. The report also proposes an optimal resource allocation strategy for making it the best use of the system's resources. The experimental results show that the proposed strategy can greatly increase the final model's accuracy while decreasing the number of wasted parameters. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload Dataset. In this module, the project starts by uploading a dataset containing training data for the machine learning model. The dataset consists of features and corresponding labels used to train the model. The dataset should be diverse and representative of the problem domain to ensure the model's generalization capability. Second module is Divide Dataset. In a distributed machine learning setting, the dataset is divided into multiple smaller subsets known as shards. These shards are distributed among multiple devices or nodes in a distributed environment. Dividing the dataset into shards enables parallel processing and distributed training, which can significantly speed up the model training process. Third module is Distribute Dataset and Run Basic DML. Once the dataset is divided into shards, each shard is distributed to a separate device or node for processing. The distributed machine learning algorithm Basic DML is then run on each device. Basic DML refers to the initial distributed learning approach where each device trains its model independently using its assigned shard of data. After training, each model's parameters are averaged or aggregated to create a global model representing the collective knowledge of all devices. Fourth module is Run Semi-DML. Semi-DML or semi-distributed machine learning is a subsequent module where the global model created in the basic DML step is used to perform further training and validation on each device. In semi-DML, the devices share the model updates with each other and collaborate to improve the global model iteratively. Semi-DML allows devices to exchange information while keeping the training process decentralized. Fifth module is Accuracy Comparison Graph. In this module, the project evaluates the performance of the trained models to detect data poisoning attacks. The accuracy comparison graph is generated to visualize and compare the accuracy of the global model and individual models from each device. By comparing their accuracies, the project can detect and identify potential data poisoning attacks that may have affected specific devices' model. Execution. For the execution of the project, we need to open the code folder. This is the code folder. To implement this project, we have designed following modules: Worker 1, worker to center server. Worker 1. This is a worker node which accepts divided dataset from center server and then build existing SVM model and basic DML model and then calculate accuracy of both algorithms and send result back to center server. Worker 2. This is another worker node which accept other half of the dataset and then run existing SVM and basic DML and send accuracy back to center server. Center server. This is a center server which upload dataset to application and then divide dataset into 2 equal parts and then distribute each part to worker 1 and 2 and then collect result. This server will run semi-DML and calculate its accuracy also. So click on worker 1. So here we have the dataset folder. To implement this project, we have used hard disease dataset. And importing this dataset contains the information of age, gender, CP, threats, BPC, cholesterol, FBC, etc. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file to start the worker 1. So here we can see that worker 1 server started. Minimize and let's open worker 2. So this is the dataset. To import this dataset, it contains the information age, gender, CP, etc. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows batch file to execute the project. Double click on run.bat file to start worker 2. So we can see that worker 2 server started. Minimize and open the center server. This is the dataset folder. To implement this project, we have used hard disease dataset. And in below dataset screen, we can see dataset contains invalid data which called as data poison. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. So this is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Now click on upload dataset to upload the dataset. Select the hard dataset, open it. So here we can see that the dataset is loaded. Now click on divide dataset to divide the dataset into 2 equal parts. So here we can see that the dataset contains this much record and this dataset is divided into 2 equal parts. Now click on distribute dataset and run basic DML to distribute the dataset. In above screen, we got results from 2 worker nodes for existing SVM accuracy and proposed DML accuracy. And in above screen, we can see existing SVM accuracy is 19% when data poison exists in dataset, and after removing data poison using DML technique, we got 58% accuracy. Now click on run semi-DML to allow center server to devote resources to DML and then remove poison from dataset and then calculate accuracy. So here we can see that we got the semi-DML accuracy. Now click on accuracy comparison graph. So here we can see that the x-axis represents the algorithm name and y-axis represents accuracy. And from above graph, we can conclude that basic DML and semi-DML accuracy is better than existing SVM accuracy. Close the graph, exit, and the final conclusion of the project is The project concludes that the suggested data poison detection systems for basic DML and semi-DML can detect and prevent attackers from poisoning the dataset and influencing the training result. The study introduces a novel cross-learning technique for detecting poisoned data and develops a mathematical model to determine the ideal number of training loops. The project proposes an improved data poison detection technique for semi-DML to give better learning protection with the help of the central resource. The project also proposes an optimal resource allocation strategy for making the best use of the system's resources. The experimental findings suggest that the proposed strategy can greatly increase the final model's accuracy while reducing wasted resources. The project concludes that the recommended schemes are viable.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.